Hey folks, welcome to the Neo4j stream. My name's Will. Sorry we missed you last week. We were out for the Thanksgiving holiday in the US, but we are picking up again this week. So if you've been following along, we have been doing the full stack GraphQL book club. We went up through chapter 4. That I think we will step away from. You can find the videos for that, though, if you're interested on the Neo4j YouTube channel, which I will link here. I won't open it up since we're streaming there as one of our destinations, but I will drop a link to it in the chat. So you can find all the recordings. If you're watching on Twitch, you can find all the recordings of our streams on the YouTube channel. But anyway, what we want to do today is kick off a new stream series. And what we're going to do is start off with building a podcast application with GRANDstack. So GraphQL, React, Apollo, and Neo4j database are the technologies we will be using. If you've been following along, so far we've done a real estate application. Let's find that. Here we go. So we did a real estate search application using GRANDstack, including importing some real geospatial data for property listings. You can find the recordings and all the code on my GitHub. And then we also did a travel guide with Gatsby, which you can find here. This was a fun one. This used our data set of OpenStreetMap in Central Park to find points of interest. We pulled in the Mapillary API to find crowdsourced images, and then we did real-time routing using the Graph Data Science library. So anyway, that was a fun one as well. So we're going to pick up a new project in that similar vein of sort of starting from scratch and building something. And what we're going to start today is a podcast application. So a few weeks ago, I was complaining about the podcast application that I was using. And someone said, well, why don't you just build one yourself? How hard can it be? And I thought, that's an interesting idea. I wonder how hard it is to build a podcast application. So that's what we're going to do starting today. So this will be, I think, a few series to get done. I'm not sure how long it'll take us, but we're going to kick it off today. So what I want to do today is talk a little bit about the data model. And anytime we start a new project, I like to think about what does the data model look like. And I go to the arrows tool, which I'll drop a link to here in the chat. So arrows is a fairly simple graph diagramming tool online that we can use to create our graph data model. So if we think of the sort of business requirements for a podcast application, well, we need to be able to search for podcasts. We need to subscribe to podcasts. I need to be able to view lists of episodes for the podcasts that I subscribe to as those are released. And then I need to be able to assign episodes to lists, I think, right? Like I want to be able to create playlists for, I don't know, like for a road trip or when I go hiking or something, some way to prioritize them. Because if I subscribe to a whole bunch of podcasts, I don't want to just see one feed with, them ordered by time. I want to be able to assign those to playlists. So following our sort of standard process for graph data modeling, the first thing we do is think about, okay, from those business requirements, what are the entities? Those become the nodes. And I can think of a few to start off with. So certainly a podcast is going to be one of those entities. And so that'll be a node. And then podcasts are going to have episodes. Episode. And we'll say that an episode, what's the right relationship type to call that? An episode belongs to? That doesn't sound quite right. An episode well, we'll say belongs. Let's just say episode of podcast for now. I think that's okay for now. And then we have users as well. So we're going to have multiple users in our podcast application, and those users are going to subscribe to. So we'll say user subscribes to a podcast. That podcast has episodes. Maybe has is a better way of saying that. So podcast has episode. Podcast has episode, reverse. There we go. And then a user is going to create a playlist. We'll say maybe owns. So we're saying owns here because maybe playlist is a thing that we end up being able to share. We'll think about that down the road. But this, if one user owns it, one user sort of has the permissions to update it. Maybe he can share it to other users later on, but we'll worry about that later. And then a playlist contains episodes. So we'll connect the playlist and episode. And sure, can use this has episode. So user owns a playlist. Playlist has an episode. Episodes are connected to podcasts, and a user subscribes to a podcast. So I think this data model defines the entities pretty well and how they're connected. Next, we can think about the properties. Well, a user is going to have, let's say, a user ID, maybe a screen name, something like that. For now, we'll just think of the user having a user ID, and then a podcast. It's going to have some sort of ID. It's going to have the feed URL. So podcasts, if you're familiar with how podcasts are published on RSS feeds. So there's some URL that when you go to retrieve that is an XML document. And that XML document has pointers to the episode files, so the actual audio files and metadata for each episode. So we'll, at some point, need to figure out how we're going to parse the feed URL to figure out what episodes we have, but we'll worry about that later. Today we're just thinking about modeling, and then we are going to implement search in our GraphQL API. It probably has a title, a description, and what else? Maybe artwork, and probably categories. Now, we probably want to model categories as a node. So something like this. that as a string, something like that maybe. And the reason we do that is perhaps we're going to have a podcast recommendation feature where we want to find the podcast that a user subscribes to. We want to find what are similar categories to find other podcasts. This might be a good opportunity for using some of the graph algorithms in the graph data science library for looking at some of the similarity metrics, or perhaps maybe we'll infer a category hierarchy. That might be interesting. Okay, and then an episode. An episode is going to have similar information as well, right? It will probably have an ID for it. We will have the audio file for it, so some URL where we can fetch the actual audio file. It probably has a title, a description, and some show notes. And then a playlist. Probably has some unique ID to refer to it. And maybe it has a name. So this is my road trip playlist. This is my vacuuming playlist, something like that. We might store, let's see, we also need the, maybe a let's call this publish. So the date time that the episode was published. And then we can also keep track of like what are the most recent podcasts that you subscribe to. So we can keep track on the relationship, on the subscribes to relationship, when the user subscribed to that. And also perhaps when the user added this episode to the playlist. Okay, good. This is a pretty good data model so far. The next step in our iterative data modeling process is, can I think of now a traversal through the graph here that answers questions that address the business use case that I have? So first of all, as a user, I want to be able to view lists of podcasts that I subscribe to. Sure, well, I just look up my username by ID, traverse along out this subscribes to relationship, find all the podcasts that I subscribe to, and grab the title, description, artwork, and render that in a list in my application. Great. I want to look at all of the episodes. So a feed in my podcast application. I want to show the user for all of the podcasts that you subscribe to, here are all the episodes ordered by the most recent episodes first. Well, similarly, I look up the user by ID, traverse to the podcast that they subscribe to, and then for every one of those podcast nodes, traverse out along this has episode to find all the episodes, order by published to show the most recent first. And so on. I can do the same for my playlists, find all my playlists, find all the episodes in each playlist. Cool. So that's a good start for our data model. I like to think of data modeling as a very iterative process. So as we go along, we may tweak this data model a bit if it doesn't suit our needs, but for a cursory start, I think we're off to a good start here. So the first thing that our podcast application needs is search, right? So I need to be able to search for podcasts before I'm going to do anything else, right? I guess we could force users to enter a podcast by URL, but that's not going to be a very user-friendly way to go about that. So there are a few ways to approach this. We need a podcast index. So we need some list of all of the available podcasts in order to build search. And there are a few indexes out there. I think the oldest, more common one is the Apple iTunes index for podcasts, which I think is available. You can sign up for a developer account and access it, I believe. What we're going to do, however, is use a newer index called the podcast index. So I'll drop a link to that in the chat. So the podcast index, I heard about this, actually, I think on another podcast. I can't remember where exactly I heard about it, but basically podcast index aims to, well, be an API for an index of podcasts. And they believe that, it's important to keep podcasting decentralized. One of the really neat things about podcasts is that anyone can publish a podcast simply by publishing your RSS feed. And then indexes pick up that RSS feed and aggregate your episodes and make them available in their APIs. So you can just create an RSS feed, submit it to Apple Index, and then it gets picked up on other indexes like this podcast index. So I like that. I like that mission. That sounds good. This is what we will use. Let's take a look at the documentation. So the podcast index API tells us how to authenticate a request. Okay, so we're going to need a key and an API key and an API secret. Okay, cool. So we'll need to sign up and figure out how to get that. But let's look at the endpoints here. So we can search for podcasts by a search term. Okay, cool. We can search by feed URL and by ID and iTunes ID. Okay, cool. And then once we have a podcast feed and we have the ID or the feed URL of the podcast, we can get the episodes. Okay, great. And then we can get the most recent episodes and feeds as well. And then we can also, if we want to publish to this index, we also have write operations for adding as well. And then here's the response structure for a podcast. Let's look at a live example. I think there's a live example here. So here's one searching for feeds by term. And the term we're searching for is Batman University. Make this a bit bigger. So we get back a JSON object. Cool. And we have a count, the query that we searched for, and then description. I guess if we didn't find any, this would say no matching feeds found or something like that. Okay, so cool. We have title for the podcast. It has an ID. So I'm guessing this ID maps to something specific to the podcast index ID. But then we also have the iTunes ID, which is more of a global canonical, since the iTunes index has become kind of the default, I think, for podcast search. Okay, and then we have description, the URL. So this is the feed URL. If we go here, we should see like an RSS feed. Yeah, there we go. So We see some XML. So we'll have to figure out how to parse that XML once we start pulling in feeds. But we'll not worry about that today. And then we have artwork, so images for the podcast. Okay, cool. Okay, great. So that looks like the endpoint that we want. So in our application, we want to be able to search for podcasts by some search term. So I open up my application and start searching for, I don't know, like Neo4j, graph-related podcasts, news, NPR podcasts, whatever you're interested in at the time. Okay, so that looks good. We also need to sign up for an account so that we can get an API key, which I have done already. There's my keys. Don't worry, that's just it's just part of the key. Doesn't include the secret. So I'll make sure not to flash those on the screen. Question from Roman. How can you implement an EAV model in the GRANDstack when the user decides what properties the entity will have? What is EAV? Is that a common thing I should know? Entity Attribute Value Model. To encode in a space-efficient manner entities where the number of attributes used to describe them is potentially vast, but the number will actually apply to a given entity is relatively modest, also similar to a sparse matrix. So is the idea here that you're sort of defining the universe of possible attributes, but many entities will only have a subset of those attributes? I guess the real question here is, how does EAV map to the GraphQL type system? Since in GRANDstack, our API layer is GraphQL, and GraphQL has a strict type system where we need to define what fields exist on what types, how those types are connected, and so on. We can make types. Types can have nullable and non-nullable fields. So perhaps you define the universe of attributes as nullable fields on a type. That's not great because you'll end up with a whole bunch of types, or a whole bunch of fields on a type. We did something kind of similar to this in the travel guide project that we did. If we look at the schema, where's my schema? So in this one, we had points of interest, and points of interest. So this data comes from OpenStreetMap, and we had tags. Where's my, here we go. We had tags, and tags can be arbitrary key value pairs that a user defines when they upload the data to OpenStreetMap. So OpenStreetMap is crowdsourced data, and this can be something like amenity is the key, and like restaurant is the value. It can be something like address is the key, and then the address as the value. It can, if it's a business, it can be something like the opening hours or something as the key. So we need a way to model that sort of arbitrary of the key value in GraphQL. So the way we modeled that was we added a tag type that had a key field and a value field, and this allowed us to store arbitrary key value tags in the database exposed through the GraphQL API, but still adhere to the GraphQL type system. So something like that sounds somewhat similar to the entity attribute value model that you mentioned. I guess this seems kind of similar, perhaps an alternative to sort of how we think of the property graph model. But yeah, good question. I guess ultimately comes down to how would you model that in GraphQL adhering to the GraphQL type system? Okay, so back to our podcast index API. We want to figure out how to use this endpoint to search for podcasts. Let's go to Neo4j desktop. So I'm going to start a new project in Neo4j desktop. Let's call this GRANDcast FM. That's what we're going to call our podcast application. Will be GRANDcast. I'll start a local database, 4.21 latest. GRANDcast. Set an initial password. We'll need to remember that later. So what I'm going to do is create a new database. And right away, I'm going to go into plugins and install APOC. So what I want to do is actually use Neo4j and Cipher to query this API. So I'm actually going to have the database take care of querying that API and returning results. That may sound a bit odd, but we'll see how we can do this using some of the functionality in Cipher. So APOC, this library that I just installed, this is really the standard library for Neo4j that has a whole bunch of procedures and functions that give us additional capabilities. One of those functions, or procedures rather, is APOC load JSON, which allows us to make network requests to JSON endpoints, like this one, and then work with the results in Cipher. So what we're going to do is figure out how to query this podcast API using Cipher and APOC. And then what we're going to do is move that logic into our GraphQL layer. So we're going to figure out the Cipher query to query this podcast index API. Then we're going to create a GraphQL API that will then expose that to our client application. Question from the chat. How do you decide if you go for a relational database versus graph database for a project? In the end, all data is more or less related, so does it make sense to always choose a graph DB for a new project? Yeah, that's a good question. There's a few things to think about, I guess. I could talk about this for a long time, but I'll try to give you the shorter answer. I think if you talk to people who have used graph databases in their projects, oftentimes you'll hear about a few use cases where graph databases really shine because they are optimized for different workloads. So, for example, things like a real-time recommendation query or a real-time routing query, where you need to be able to traverse a graph very, very quickly, and you have like tens of milliseconds because this query sits on the hot path for loading a page in an application, or you need to figure out the logistics route before the package comes off the conveyor belt, something like that, where performance for these sort of traversals is really key. If you have some use case like that, yep, totally makes sense to use a graph database. Something like fraud detection, where you're dealing with in a financial services account, financial services institution accounts and users and transactions that occur at merchants, and you have lots of this connected data, and you need to be able to model the complexity of that, and also maybe leverage some of the tooling like visualization, graph algorithms that can help you analyze that. Yeah, totally makes sense for using a graph database. I'm going to go for a graph database in those projects. And then you have other kinds of projects like, for example, you might call them like CRUD apps, where I'm building a podcast application, or I'm building, I don't know, like a blog, maybe like a Medium type publication, something like that, where it's not clear necessarily that there's the ability to take advantage of the complex nested queries that I'm going to deal with a graph database, and another database might be acceptable performance-wise. I think another aspect to consider, though, is the data modeling. Like, how can you express the complexity of the application data? So if we look at like our podcast application, we could model this in a relational database as an ER diagram and have some join tables. That's okay. That's doable. It's a lot more natural, though, I think, to express your data model as a graph. I think we think in terms of graphs, how entities are connected, and so on. So as our data model gets more and more complex, you don't have that impedance mismatch of how you think about the data versus how you store the data versus how you use the data in your application. And then when we add how we want to expose this data to the client, and we start talking about using a GraphQL API, that then introduces a whole nother layer of, zoom into this diagram here, a whole nother layer where the data model that we're working with in the database then is the same data model that we're then exposing as a graph to our client application. So again, we don't have this mapping and translation layer of going from like a relational database to a graph model for our GraphQL API. We just sort of have one schema to work with for our API application and for the database. So anyways, it also comes down to what sort of tooling exists for your ecosystem as well. I think that's a really important consideration, right? So with GRANDstack, I know that there's good support for working with GraphQL and Neo4j in the Node.js ecosystem. So I know that those sorts of integrations for that sort of full stack framework is there. I know I can deploy that on different services. So that's another consideration as well. Anyway, I could talk about that more nuanced aspects of that for a while, but I'll leave it at that. Hopefully that at least gives you some things to think about. Okay, so what I want to do is use this APOC load JSON procedure to query my podcast index endpoint and search for some podcasts. So the first thing we need to do, let's open up Neo4j browser. Let's make sure we don't have any data in here. I did start a new one, right? Yep. So empty database. And then let's make sure that we installed APOC. Yep. We've got APOC procedures. Cool. So if we look at this, we can actually, let's look at an example. Import from Stack Overflow API. So we start off with the URL. So this is very similar to the podcast index API that we're about to query. Let me make this a bit bigger. Where is it? Here we go. Where we have some query parameters for like what we're actually searching for. This one has a bunch of things in there for searching for questions on Stack Overflow. Then we say call APOC load JSON. We get back this value. So this is now a JSON object, and then we can iterate over that using Cipher. Okay, cool. So that's kind of what we want to do. If we look at this endpoint, it says, oops, says hit this endpoint. So what we're going to do is call APOC load JSON yield value, return value. So we'll just use their example. I spelled yield wrong. And it says that server returned 401. So we are not authorized to make that request without sending an authorization header. So we use an Amazon style request authorization token. Okay. And we have to set a bunch of headers. Okay. So we need to set a user agent header. So what application are we sending this from? We need the current time. Okay, cool. We need the API key. Okay. And then an authorization token, which is a SHA-1 hash of the auth key, the corresponding secret, okay, and the current date time encoded as a hexadecimal value. Okay, cool. So we need to add some headers to our request. So fortunately, this procedure, APOC load JSON params, will allow us to add headers to our request. So we can put our authorization in there. So like I said, I signed up for a free developer account and I got a API key and an API secret so that we can make authenticated requests. Anyone can do that. Just go to podcastindex.org and put in your email address and you'll get free access. This is an open API. They just have tokens so they can, I don't know, revoke you if you abuse it or something. I'm not even sure if there's aggressive rate limiting or anything like that. Anyway, so you can sign up for API keys. I already did that. And what we're going to do now is change this to APOC load JSON, oops, APOC load JSON params. So we're going to pass the URL, and then we're going to also pass our headers. And then I think we also need some other arguments, but we'll leave that out for now. So, okay, so now what we want to do is it needed what? A user agent header. So this is going to be GRANDstack. We need auth date, was it? So this is going to be some timestamp. So we have a timestamp function. I think we need to convert that to a string. We'll fiddle with that in a second. Then what else was there? There was x auth key. X auth key. This is my URL key. So some secret. X auth. No, it's not X auth. The next one is just authorization, right? Yep, authorization. And this one, this is some like token that we have to concatenate a bunch of things and SHA-1 hash it. Okay. So the first thing we need to do is figure out, how do I get my secrets in here? APOC has, let's find it here. APOC has static values that we can store. Is that in text maybe? No. Cipher execution, NLP background operations, operational. Let's search for it. APOC static value storage in the miscellaneous category. Miscellaneous static values. Yep, there we go. Okay, so I can store values in the Neo4j configuration file and then reference those with APOC static get. So if I go here, it's not this file. There's actually it actually reads from apoc.conf file. So if I, let's see, open terminal. This is going to open a terminal to this installation of Neo4j. So this instance. So then in the conf directory, what I want to do here is create a apoc.conf file where I'm storing. So it's going to be something that looks like this, like apoc.static dot, let's call it podcast key, and apoc.static dot podcast secret. So this allows me to define secrets without having to write them in my Cipher query. I can just store them in my configuration file. Let me go back to, where did that terminal go? So I'm going to do this off screen here because I don't want to type my credentials in the recording here. So I'm going to create two values in an apoc.conf file, apoc static podcast key, apoc static podcast secret. Okay, so those are in there now. So now I can reference those by saying apoc static podcast key. Okay, so let's figure out this timestamp. So the timestamp, it says epoch time as a string. Okay, so unique epoch time, which is milliseconds, is an integer. Does not include a decimal point. Okay, so I want this in seconds. So I have this, there's this timestamp function that gives us milliseconds, but I want seconds. So let's move this up here because we're also going to need to reuse this value when I concatenate things in the authorization token. So I'm going to convert this to a string, and it's going to be the result of the timestamp function, which gives me milliseconds divided by 1,000 to give me seconds as timestamp. So that's going to be a string here. Podcast key we're reading from apoc, and then the authorization token it says is the SHA-1 hash of the key, the secret, and the date value concatenated as a string. Okay, so fortunately, if we go back to our apoc docs under text functions, and I think this is at the bottom. Yeah, here we go, hashing functions. So apoc to the rescue again has a apoc.util.sha1 function. Sweet. So we can say apoc util sha1 and apoc static. Oh, right. It's not apoc.static.podcast key. It's apoc.static.get. And I need to specify what value I want to get from the static value store. So when I get the podcast key, and this is going to be apoc static get. It's the key first, concatenated with the secret, concatenated with the timestamp. Okay, let's try that. Expression in with must be aliased. Oh yeah, with this as headers. So this object that I'm creating here is going to be alias to the headers variable, and then I'm going to pass that in my call to apoc load JSON params. Okay. Procedure call does not have the number of arguments. Yeah, so there's like some other configuration things here. What, a payload, which I don't need to send a payload, and then some configuration I don't need. So yeah, we'll just put empty strings for those two arguments. Okay, and we still get a 401. Oh, I think, I need to restart the database after changing the configuration so that those configuration changes get picked up. Roman in the chat says, I'm eyeing Neo4j for implementing access service. Need to be able to inherit permissions across your organization structure. Yeah, identity access management. That's a great graph use case. When I did it in a relational database, tried to document, couldn't think of anything better than drawing a graph. Yeah, that's another, going back to talking about sort of like the core use cases and reasons for using a graph database. When you start thinking about those complex identity access management rules, a graph is a great way to represent that. And that is a very non-trivial problem to model and reason about, for sure. Okay, we restarted the database. Let's try this again. There we go. So the reason we had to restart the database is because I added those values to the apoc.conf configuration file, and we needed a restart to pick that up from the store, from the static store. Cool. So we searched for the Batman University podcast. That's just the example that Podcast Index had in their docs. I'm not familiar with that one. Let's change the search term to Neo4j. And we should get back we get back Rick's Graphistania podcast. Cool. Okay, so we know how to write this in Cipher. What we want to do now, though, is create a GraphQL API to expose this to our client application. And to do that, we're going to use GRANDstack, of course, my favorite full stack framework. And what we're going to do to get started really quickly is use this create GRANDstack app, create GRANDstack app CLI, which is nice because I don't really have to install anything other than to have Node installed. So we're going to say npx create GRANDstack app. So this is going to skeleton out a new GRANDstack application. And let's call this GrandCast FM. So this is going to download the latest release of the GRANDstack starter project and then ask us a few questions to configure the application. Okay, it wants to know which front end do we want. Let's come back to this. Let's do API only for now, since we're just working with creating the API. Yes, we want dependencies. No, we don't want to get repo. Yes, I have a database. It's the default localhost. No, I don't need encryption. Default user. And the password is let me in, which is the password I use for everything. Okay, so this is now installing dependencies, removing any front-end templates. So you saw there are a few options now for the front end in a GRANDstack app. There's React TypeScript, and then some folks from the community have added Angular, Flutter. And there is a Vue one now that Adam implemented. We just need to add that to the CLI. Okay, so we installed our dependencies, and now it's ready to go. So we're going to cd into GrandCast FM, and let's just go to the API directory and open that in VS Code. And we'll fiddle with our window sizes here. Hopefully we can see enough of that. Okay, so if you're familiar with GRANDstack applications, we have a GraphQL schema. The default, let's look at the GRANDstack starter project README. So the GRANDstack starter project starts off with a business reviews application. Let's look in React. Yeah, I can see some screenshots, sort of. Anyway, it's a business reviews application that has scripts also for seeding the database. We can also seed the database. I closed the CLI, but it had the command for how we want to, we can seed the database with some fake data according to this business reviews schema. So it gives us a schema for like users that are reviewed a business. And then there's a dashboard UI, and then like a business search UI that shows how to use GraphQL with the different front ends. I'm going to start with a blank schema, so we'll just delete that. So all I want to do today, though, is expose this podcast index search in my GraphQL API. So I don't actually even want to store data in the database right now. I'm just using the GraphQL API and Cipher as a way to expose that API for searching for podcasts. So I want a query type, and make this a bit bigger. There we go. And we'll have podcast search, which is going to give us, let's call it podcast search results. And then our podcast search, search result, singular, and then the brackets indicate this is an array type. So podcast search result is going to have what, like that iTunes ID. Let's call this, I guess it doesn't matter actually, since we're not storing this in the database. Anyway, a podcast search result is going to have an iTunes ID, a title, a description, a feed URL, artwork, and so on. Okay, so I'm not fetching data from the database. So if you're familiar with the Neo4j GraphQL integrations, let's back up a little bit and take a look at that. Let's look at the quick start. So the Neo4j GraphQL integration is called Neo4j GraphQL.js, and the goal of Neo4j GraphQL.js is to make it easier to build GraphQL APIs backed by Neo4j. So we create GraphQL type definitions, and then those type definitions inform the data model in the database. And then we're able to provision a GraphQL API with data fetching logic. So all of the create, read, update, delete operations are just sort of generated for us automatically from these GraphQL type definitions. So it's a really, really nice way to get a full GraphQL API up and running without writing any like boilerplate code. So that's really nice. We can also use it though to add custom logic using Cipher. So we can attach Cipher queries to fields in GraphQL. We can do that for fields, like scalar fields on a type. We can do it for object and array fields as well. We can also do it for top level query and mutation fields. So what we're going to do now is for this query field, podcast search, the logic for this is actually going to be defined by a Cipher query. So we add that Cipher schema directive that says, hey, bind the results of this field, in this case, the root level field for our API, to some Cipher statement. What Cipher statement? This one that we just wrote. So I'm just going to copy paste that. So now we'll have this podcast search field that anytime we request that in the GraphQL API, we're going to execute the Cipher query. And we need to make sure, though, that the results that we return map to this podcast search result object. So instead of just returning value, what we need to do, if we look at the example, this one. So this object here, this is what we're saying is the podcast search result object, and that is embedded in this feeds array. So we actually are going to want to unwind and iterate over that. So we're going to unwind value dot feeds as, let's call it feed, and then we're going to return iTunes, return an object with the key iTunes ID is going to be feed dot iTunes ID. Oops, not iTunes, not Intunes. iTunes. Title is feed.title. Description is feed.description. Feed URL is feed.url, since it's called URL over here. And then what else do we have? Artwork. Artwork is feed.artwork. Okay, cool. So we're gonna unwind over this feeds array and return objects grabbing some values out of that feeds array. Cool. Let's take a look at index.js so we see what's going on here. So we're importing those type definitions that we just wrote. We're getting Apollo server. We're getting a Neo4j driver instance. We're getting this make augmented schema function from Neo4j GraphQL JS. We're reading some environment variables, which if we look at that .env file, these values these are just the defaults, but they were populated for us with that create GRANDstack CLI. So when it asked us what is the connection string for the database, do you want an encrypted connection, that populated this file. We then create a GraphQL schema object by calling Neo4j GraphQL JS's make augmented schema. So make augmented schema, it takes GraphQL type definitions and then generates resolvers. So resolvers in GraphQL, those are the functions that are actually responsible and have the logic for fetching data from the data layer. So those get generated for us, so we don't have to create those. Typically, when you create a GraphQL executable schema, you're attaching the type definitions and the resolvers. But because those are generated, we don't have to write those, which is really nice. Oftentimes, there's a lot of boilerplate logic that goes into writing those. Then we have this configuration that is excluding a type. We'll leave that for now, but we'll come back to that in a second. Then we create a driver instance that connects to our Neo4j database, reading the values from that .env file. We do this initialize database process, which I'm going to comment out. I'm going to skip that for now. We'll come back to that. Then we create an Apollo server instance, passing in the driver instance, so the connection to Neo4j, and passing in the executable schema. And then we apply any middleware if we have it. We don't have any middleware to add now, and start up our API. So let's get a terminal and npm run start. It says our API is running on localhost 4001 GraphQL. Here's GraphQL Playground. If we look in the docs tab, we can see, hey, cool, we have some queries and mutations. So this is interesting. We have podcast search. So if we go back to our schema, podcast search, yeah, that's the query field that we added here. But note that our Neo4j GraphQL integration has also added a podcast search result query field, and then create, update, delete, merge mutations for that. So the default convention is that any types that I declare in my schema, that maps to nodes in the database. And then I can define relationships between types, and then that also maps to relationships in the database. But that data model then informs the create, update, delete operations that are generated as part of the generate API. But because I've written the logic here for this query field, I want to exclude the podcast search result type from the generated queries and from the generated mutations. So we'll add those now into the configuration to exclude. We could also use a directive here to do that, but we have it in the configuration here. And that change didn't get picked up. All right, I want to do npm run start :dev, I think will give us, dev mode that has a watcher, and also log our generated queries. So now if I refresh GraphQL Playground, I now only have one query field. So those generated query fields, query mutation fields, are no longer there because I excluded those in the configuration. Okay, cool. So can I search for podcasts yet? So let's say podcast search. Podcast search doesn't take any arguments yet. Can I get a title description? Okay, cool. Well, it found the Graphistania Neo4j podcast. If I look at the Cipher query here, well, that's because for the search term, I just hard-coded Neo4j. So, okay, we've implemented a podcast search API that only returns the Neo4j podcast. Okay, that's a good podcast, but we may want to find others to listen to. So what we're going to do now is add an argument to this podcast search field. Let's call this search term. This will be a required string. So we need to specify a search term. With these Cipher directive fields, anytime, make this a little bigger. It's hard to fit all that code on the screen though. Maybe let's slide this over a little bit. Give a little more space for our code here. But anytime I add a field argument to a field that's using a Cipher schema directive, whatever I've passed in for this argument value gets passed as a Cipher parameter to the Cipher query here. So what that means is I can replace this where the Q query term is hard-coded. I can then concatenate that with the search term Cipher parameter. So if I refresh that, I need to refresh Playground for it to know that I need to pass in a search term. And now we can search for, the Neo4j podcast. make sure that didn't break anything. But now we can also search for, I don't know, maybe like NPR podcasts. What's your favorite podcast? Drop the name in the chat, and we'll see if we can find it. Okay, and I can add like the artwork, the feed URL, and the iTunes ID. So I can now get all of this information. Cool. What else? Oh, we said we had categories as well, right? Conrad says the Accidental Tech Podcast. Oh man, ATP. That is one of my favorites as well. Accidental Tech Podcast. Failed to invoke illegal character. Oh, right. So we got an error because the URL just took our search term exactly, including the spaces, and tried to hit that URL. So we need to URL encode the input. So I think APOC is going to save us again. Are we on the text page? We are. We don't want base 64 though. Is this one of our text functions? No, we were just looking at the text functions. Is it a miscellaneous? Utilities, text and lookup. No. I know we have a APOC URL encode. Oh yeah, it is one of the text functions. APOC text URL encode, return the URL encoded text. So that's what we want to do to kind of sanitize that user input. Is call apoc.text.url encode. So this is going to encode those special characters like spaces and slashes and things that we can't include in web URLs. Cool, there we go. So now we get the results. So Accidental Tech Podcast, 3 nerds discussing tech, Apple programming, and loosely related matters. That is a good description of it. If you are familiar with ATP, it's basically 3 nerds talking about Apple devices for an hour and a half. What else? Mac Break Weekly. Let's see if we have that one. Mac Break Weekly. Yep, got that one. Latest Apple news. Cool. We can search for, if we just want to like search for news podcasts, we'll find a bunch of things. But I think we also want to return categories to help us make some decisions. Does this not have categories? Where are my categories? Oh, this one just doesn't happen to have any. Let's go back here. Look at our Neo4j example. Yeah, here we go. Here's categories. So categories is actually an object here. Okay. I don't want to represent categories as an object. I don't know what the key is. 102. This might map to like how, I don't know, iTunes does podcast categories or something like that. Let's treat categories as a string array. And what we need to return then is feed.categories. What we want to return, though, is just the values. So if we had a values function in Cipher, we could do that. We don't. However, we do have a keys function, though. Does that just work on nodes? I think that works on any map, right? Yeah, so if we add, let me refresh so it picks up that I have added categories as a field. So I can add categories. And I get the keys of the categories. That's not very useful. So what I want, though, is to transform feed.categories, this object. I want it to just get the values from that. And I think we're going to use another APOC function. So if we go to map functions, and take a look at apoc.map.values, takes a map and the keys that we want to get the values for. So we can say apoc.map.values. What is the map or the object we want to get the values from? It's feed.categories. And then we want to get all of them. I don't know if that's a default, but we can say keys feed.categories. We just saw how to use that one. Okay, so this should transform feed.categories from the podcast index API into, from a map into just a list of strings. Let's try that. Yeah, there we go. So this podcasting news daily business technology. If we go to like NPR, let's search all the NPR podcasts and see Here and Now is arts, 1A is news, On Point is arts, Invisibilia doesn't have any categories, and so on. Cool. So here is our podcast search API. So we now have that. So our users can search for podcasts. We haven't actually stored any data in the database yet. So it's kind of interesting. We've just sort of used Cipher to query the podcast index API, and then we created a GRANDstack GraphQL API and bound that Cipher query that we're using to fetch data from the podcast index using Cipher. Now, what we need to do, though, is actually store data in the database. So a user searches for a podcast. The next thing they're going to do is subscribe to it. So when a user actually subscribes to a podcast, then that's when we're going to write data to the database. So we don't want to like replicate what the podcast index is doing, right? Like it's a search index. It's keeping track of anytime new podcasts are added to like iTunes and making sure that those are updated. And it's a free API. So we don't want to replicate that functionality. We don't want to build a podcast index. We only just want to keep track of, for our users, when they've subscribed to a podcast, then we'll store it in the database and connect it to that user. So that is what we will pick up next time. I think this is a good spot to end for today, since we created a little bit of functionality here. I will push this up to GitHub. Let me create the repository now so I can at least drop the link in the chat. What should we call this? GrandCast FM. public create repo. Cool. So Grandcast FM, here's the link. I'll drop that in the chat. I'll push up the code for this later on, so you can find it there. And then you can also find the recording for this stream and all the others on the Neo4j YouTube channel. If you're not watching on YouTube, that's where it is. But you can also find these on my website. So I created recently a videos section on my website, so you can find recordings of it's mostly just these streams. And then a couple of meetup and conference talks I did. But anyway, I just thought that would be a good place to add some of the videos, recordings of the streams and whatnot. It's nice also that I'm also capturing any links that might be relevant as well there. Cool. Oh, I also recently created a newsletter. It's just sort of a personal newsletter sharing things that I've been working on. You can read some of the previous issues here. So, for example, some blog posts using the new Neo4j charts, Graph App, and Bloom. So anyway, if you want to keep up with kind of what I've been working on, you can subscribe to that, and you'll get in your inbox blog posts and things that I'm working on. Anyway, that I think is a good place to end it. We'll pick up next Thursday. So we do this stream every Thursday at 2 p.m. Pacific. And like I said, the next thing that we need to do is figure out now how to store podcasts that users have subscribed to. So I guess the first thing we'll need to do is figure out how to deal with users. So maybe we'll just build a user authentication is probably the next thing, right? So a user needs to be able to like sign up for our podcast application and create an account. And then they need to search for podcasts and then subscribe to a podcast. So we'll try to implement that next time with creating users and then users searching for a podcast and subscribing to a podcast. We'll do that next. Cool. So thanks everyone for joining today. And we will see you hopefully next Thursday at 2 p.m. Pacific. All right. Cheers. Bye-bye.